So we have to come up with a distance time graph. So for A, all of them, we are plotting time on the x-axis and distance on the y-axis. Pardon? Okay, so in the first example, who wants to read it? From the motion sensor, would she start at the origin or above the origin? So she starts 10 meters from the sensor, and she's going towards the sensor. Is the line going to go up or down? She's going back towards the sensor. Down. Think about it. She's starting 10 meters from the motion sensor. So already she's away from it. She needs to go back towards it. We need to go back down towards the x-axis. That's where the motion sensor is. Okay? How about B?
A stands 5 meters from the motion sensor.
Okay, so again, we're looking at time and distance. You're drawing the graph. He's standing 5 meters from the sensor. So am I starting at the origin or am I starting above the origin? Is it going to be higher or lower than the question A? Lower, because it's 5. Now, it doesn't say he's doing anything. He's just standing at the motion sensor. He's not moving. So what kind of line am I going to draw?
Straight.
Good, horizontal. He's not moving. He's just standing there. That's it. Okay, and then finally the last one, Anthony.
He starts.
Anthony starts 1 meter from the sensor and walks away from it. Slowly. Yes, thank you. So he's starting 1 meter from the sensor. So this would be around 1. If he's walking away from the sensor, am I going to draw a line that goes up or down? Good. He's walking slowly, so we don't want it to be very steep. So what's happening? Ernesto is riding his bike at a constant speed from school to his house. Okay, so he's going from school to his house. So if I were to draw a graph, we're looking at time and distance from what? School or from his house? If he's at school, he's away from home. So we're looking at the distance from his home. Okay? He's riding his bike from school and he's going back towards his house. So they've given us the equation, which is showing that his distance from home is related to the time in minutes. Can anyone describe what this equation means? What is his distance equal to?
42.
42 minus 30t. What does that mean? T stands for time, yes. Now, if the starting point is 42, that's the initial value. So we're going to plot that on the graph right here. Okay, 42. What does that mean in this scenario? Distance is in meters. Ernesto is 42 meters from where?
His house.
Yes, copy this down. Ernesto is 42 meters from home. Good. Okay, where is he? Where is he? Pardon? He's at school. So we know automatically that his school is 42 meters from his house. Ernesto is 42 meters from home. He is at school. And then his distance is decreasing, which means he's getting closer to home. Where's he going? From school to? His distance is decreasing. So is my line going to go up or down?
Down.
What is his distance decreasing by? Look at this part of the equation. It says 42, take away 30t. 30t. What is the rate of change? 42 was his starting point. That's his initial value. And this is the rate of change, which means this, 30t is the rate of change. It means that he is riding his bike, I hope we're copying this down, towards home at a rate of what? What's the rate of change, Rick? 30 meters per, what's T? What's time in?
Time.
In what? Seconds, hours, what?
Minutes.
Thank you. Read the question.
I did.
So Ernesto's 42 meters from home. He's at school. And he's riding his bike towards home at a rate of 30 meters per minute. See how we gathered all that information from the equation?